everyone. Thank you for having me. My name is Sergei Chernov, and today I'm gonna talk about a problem that most of the Java Kotlin developers experience. The name of the presentation is Domain Errors and Functional Error Handling in Kotlin. So I hope you guys have some experience working with Kotlin, but if you are not familiar, it's still okay to listen. So here's some information about me, and if you want to connect with me on LinkedIn, you can scan QR or find me with the post in LinkedIn. Okay, so the problem I wanna talk today, it is when expected business failures are hidden in implementation. So if we check the code example here, the method the method signature doesn't show anything what is happening inside. So imagine the legend is this method or this API maybe, it does signing a document with some code. So what can go wrong with this method when you call it? So the code can be invalid, the signing window period can be expired, a document can be expired or can be signed already, or maybe some database outage. So something can go wrong, right? And I think many Java developers experience these questions, these problems when they just read the code from the interface perspective. So to answer what is going inside. So to answer what is going inside the method, we need to dive deep inside the method implementation, right? So it is not enough to just read the method contract. So the business failures, they are hidden inside the method implementation, and if you want to handle the business failures from caller of the method perspective, you need to know what to expect. And this can be very challenging, especially if you work with someone else's code or you didn't touch it long time, or when you work with some vibe code like agentic code. So the name of the presentation has functional on it. So what we put on it? So the functional handling means you try to make your methods pure. You try to avoid some hidden flow. You try to remove any side effects, and you have the method arguments, you have the input, and you expect for the method to return something. So the best for the functional handling, when you have everything to work with your method, you don't need to look inside the method implementation. You just read the contract. So we don't talk what the either here. We will come back later. But for now, we say that we want for our method contract, for our class contracts, interfaces, to tell what will happen when we call the method, and what to expect when we call it, what to handle if it has any failures. So I want to propose some categories for expected business failures, and I say there are 3 categories. First, API client errors, the user domain errors, and the third, unexpected exceptions. So what is API client errors? For example, if we talk about REST API, your REST API can receive an invalid JSON or missed required headers, or some request can come out of the flow, right? So when you have some steps in your flow and the request doesn't follow the steps, or the resource can have no access for the user or something else. So what is special about this case? You don't need to, in general, you don't want to distinguish these cases, these kinds of errors. You want to collapse them in just one invalid request or something not found, right? So basically your user, they will not see that on the UI. Your designers will not create any designs, any pages for that. So this category is API client error, when your API client or your mobile app is not like healthy or something. So another case is domain errors, when your API client or mobile client, it behaves healthy and the user can experience the business failure. For example, if we talk about signing a document, the signing can be invalid, the code can be invalid, the document can expire, or the something else, the policy can reject the request, or access can be revoked from the document. So for these, designers usually propose some handling cases to show the user the proper error message. So in that case, you want to distinguish all the business failures from each other. And the third category, unexpected exceptions. So this what you want to represent as internal server error when we do a REST API. So for example, database unavailable, request timeout, network failure. Here we also put some production bugs when you see some null pointer exception or any invariant when it's broken or illegal state. So these errors, usually you don't expect, you don't consider them business failures. They are unexpected and you don't want to react on them. You just need to return the general error, like internal server error, and what will the client side see, just something went wrong, right? So how to handle the unexpected error? As I said, you just show the internal server error, you say something in your logs, you put the error in metrics and alerts. So it takes, like, you consider it as an infrastructure failure or something. So why we have the problem with the unexpected business failures when we do just classic Java Kotlin development. So look at this slide. I think many Java developers here will code the business logic to validate the conditions throwing runtime exceptions. Can you raise your hands who does any Java Kotlin development here? Just few people, okay. And who does any backend development? Okay, so maybe other people who don't do Java development can still understand what is going on and can still experience the problem. So here, the implementation does something hidden behavior, some hidden failures. You throw the runtime exceptions, and if you have a code from the client side, when you call this method, you don't know what to expect, how to handle these exceptions. For example, if we talk Kotlin, you expect that compiler is your friend, but in this case, compiler will not help you to catch them, right? So you need to just define all of the cases, and use else branch, and if someone else touches this code, add a new exception later, your client-side code will not see the new exception, will not get broken, and I hope you guys just cover with many tests this this code. So now I think you can see the problem here. So what we want to do? We want to make our methods have something in the method contract to represent the business failure. So historically, Java tried to address this problem with the checked exceptions. And if we see the slide, it looks how we want it. You can distinguish the exceptions from each other, and if you don't handle them, the compiler will not allow you to run the application, to compile, right? But this approach didn't scale well. There are some cases you can just ignore the checked exceptions, and the most bad thing that later Java introduced a stream API which doesn't compose with a checked exception. So you need to do some sneaky throws, you need to do try catching, and you return back to runtime exceptions, and your compiler will not help you again. So this approach didn't work well, unfortunately. So how to address this problem if we don't know anything about the either approach, but we have some sealed classes, sealed interfaces in our language? For example, in Kotlin, we have sealed interfaces. I believe other languages like Go have something similar, right? So with the sealed interfaces, the compiler knows every child of the sealed interfaces, and if you define the result type as sealed interfaces, like here, document sign result, you define a success result, and you define a business failure. For each business failure, you extend the document sign result. So this approach will work. The compiler will see all the branches, and if you do the when pattern matching to handle all the cases, the compiler will help you, and it will look like this. So I don't know, since not many people are Java developers here, I don't know, raise your hand if you work with the business failures in that way or similar to that way. 1, 2, 3 people. Okay, we can hire them. Okay, so this approach is not bad, and you can try to improve it. So naturally, if we do just the first attempt, right, for each result type, we need to define the business failures like very verbosely, and you can try to distinguish the two types, the success result and the business failure, right? So in that case, your handling code will look better. So you just extend the business failure for the failure branches, and you just distinguish, is it success or business failure? So this code looks better for me. What if we try to improve it more? So in that case, we already know that we need just two cases, success and business failure. So we can put the error as a value field inside a business failure and make a error a union type. So here, document sign error, we call it error, domain error union type. And for me, it looks good. So the handling looks better, but for each result union type, we need to define new union type like document signed result, document create result, and many more. So this also kind of verbose. So how to do it more better? So we just invented either when we tried to use sealed interfaces and union types. So what is either? It is a union type when it's either success or a business failure. It is left or right, and the compiler can prove that it cannot be both, and it's always left or right. So it is a generic class, so you don't need to invent the either for each method. So it's kind of composable. And to use it, we don't need any library. And if we talk not only Java development, we can reinvent either in any languages which has a sealed interface or something. So for either, as I said, we need a sealed interface union type with generic left or right fields, and we need some helper methods. We need a method like left or right to construct the left or right value, and we need some methods to operate on the value and compose them. So we need map, flat map, fold, getter, else. And basically it feels the same way how you work with optional. So the Java already has optional, the Kotlin has nullable, and most of the Java developers are familiar with that, and they know the map, flat map, and everything. So basically optional can be considered as either with unit as left side. How cool is that? So if we use this approach, the failure, the business result, you put the either and your union type of failures inside the method return type. So your method contract becomes readable, and the compiler can help you to handle all the cases of the business failures. And how to construct the business failure, you just use the helper something function like left to construct the business failure, and you use right to construct the successful result. So if we talk about either, and we say that either feels the same way how you work with optional, and if you try to compose the methods that return either, you can see the code will look a bit ugly because the nested brackets, and it doesn't compose well. So what you're gonna do is that there are some approaches how to handle it. So you can try to just flat it, but this approach doesn't look perfect, but still works. What else? You can try to do early return, and this code for me looks better. It's very flat, but if you add some library, like for Kotlin, you can add arrow Kotlin library, and it has some syntax to just compose the either. So you have either keyword, and you have bind helper method to unbox the either. So if bind is called on the left side, the execution just stops, and the either returns the left right away. So for me, now the code looks much better, but the contract of either doesn't change. So it is the same code how you do it without any library. And the either ID and the arrow library, the Scala language influenced the arrow library, and the Scala language has a for comprehension and the arrow method to compose the either. So here how it looks in Scala. Do we have anyone who worked with Scala here? Oh wow, hello guys. So this is the example how you will design the error union type. You will put your API client error cases, and you will put the user domain errors. And you can see that we don't put any unexpected failures. So common mistake is to put database unavailable business failure or network error business failure. So don't do that, guys. You just let them be called by the global exception handler. So let's talk about common mistakes if you try to use this approach. So many people will try to use either, so their code methods will not throw any runtime exception, and they will stop on that, just they will be happy that the problem is solved. But look at the return type. So the return type is either throwable. So when you call this method, the compiler doesn't know how to handle the business failures. The compiler doesn't know anything about business failures, and when you design your methods with either throwable, it is basically the same how you work with throwing runtime exception. You just don't do the throw, but the problems, all the problems of the approach are still there. And the Kotlin has the result type in the Kotlin standard library, and this result type didn't work well, and the Kotlin developers, they admitted that this approach didn't work out, and they don't recommend you to use it. So either throwable is basically the same as a result in Kotlin. So here the compiler doesn't help you, but we want to make compiler our friend. So what are the other typical mistakes? So some other people, they say, okay, we will use a broad union type for all the methods the class has. We will return the one union type. So for example, here we can invent a document error, and we have like 3 methods, and we will reuse it in all methods because we don't like repeatable code. We want to like reuse something, right? And this approach is better than the either throwable, and the compiler will see all the branches, and you can think, oh, this approach works well, but with this approach you will have some branches that impossible to get. For example, if you return template not found in something expert failure, you use expert failure error in an expert document, but you will never return it from signed document, and when you handle the return value of each method, you will always have to work with expert failed business failure, and the compiler will not see that this error will not be returned from the method. So this approach is not perfect either. So what is the recommended approach? I recommend you guys to define a narrow union type for each method. So if you have 3 methods, we should define 3 domain error union type. For signed document, we define document sign error. For prepare signing, and for expert error. So in that case, we only have to handle necessary branches. We don't have any else cases. We don't have an impossible to reach line. And I think this approach is not hard to use, and it works very well. It addresses the problem. The compiler knows all the cases, and no hidden error flow inside the method. So what changed? We tried throwable, we tried broad union, and the best way is per method error union type. So how to work with either in general with your Java project? If we talk about REST API, for example, you try to return either from your service layer, from your repository. You usually work with nullable, but it's okay to return either from there also. And when you work with the controller or API layer, you need somehow to transform the either union type value to an HTTP response. So the general advice just to do map left, or to map the error type to the HTTP response. And as I said before, we don't encode the unexpected business failures inside the domain errors. So in here, for example, we will map the business failure to the some bad request, I think. So another benefit from this approach, consider you have a server API Java project, and it is common approach to publish the API client. So your other Java projects, other Java teams can just plug in your API client with published data transfer objects. It is a common approach, so why not publish a error union types as well? So for example, we just can reuse the same method contract from the service layer inside the client API client interface. I think it's also cool. So your client handling will be consistent with how you handle the exceptions, business failures inside the server project service layer. So as I said, it's a common approach to do some sharing, and we talked about it already, so let's go next. So what is the next benefit from this approach? When you do code review, you don't have to dive deep inside the method implementation. You can just read the method contract for have some brief understanding what is going on in this merge request, and you can, for example, compare the API client contract and an open API specification with the just your service layer interfaces. So as I said, Kotlin has a result type historically, but in modern versions, they propose Kotlin rich errors feature, which look similar to what we see with the either approach. And here how it looks, and they want you to benefit from the short circuit question operator. So as I said, if you want to use either effectively, I recommend you to use Arrow library for Kotlin. It has either type, it has some syntax to compose it, and it also has some types from functional programming, like non-empty list, for example. So as I said, the ideas are not new. They are taken from the existing languages like Scala. And Scala has the either and the composition inside the language, and it has a rich functional programming library cats. Who knows what's the cats in the naming? What does it mean? Okay, can you raise your hand who is familiar with the cats library? Okay, move on. So let's talk, probably most of the Java developers, they work with the Spring. And if you want to integrate this approach into existing Spring application, you want to answer the question how to integrate the either with the Spring controllers, REST controller, and I recommend you two approaches to use. So the first one, you return the either from the service layer, and inside the controller, inside the methods, inside the controller, you just do this throw and you map the error business failure type inside your runtime exception, the custom runtime exception, and in Spring, the common approach is to define a custom runtime exception and to define a controller advice global exception handler, and just to map the runtime exception, to catch the runtime exception in the controller advice, to map it to the proper HTTP response. So this approach will work, and you don't need to change too much. But if you want to return the either directly from the controller methods, you can do that also, and you need a response body advice to implement. So if you want to integrate the either approach with the existing code base, and you have some classes, some methods, some code that throws a runtime exception, you can rely on an adapter pattern. You can just define some methods returning either, and inside the methods you just do try catch and map the runtime exceptions to the proper left business failure type. And if you work with a database in your Java project, you also need some adapter code. You need some helper method, which will roll back the transaction on the left returned value, and then how to roll back, just throw your custom exception, and then after you roll back the transaction, catch it and return the either left again. So from the code perspective, it will look like you work with the transactions with the either directly, but inside the helper method implementation, you will do some magic with rolling back the transaction on the left side. So if we talk about trade-offs of this approach, we have more types, more mapping code, and your signatures become more verbose, but you will benefit from the compiler that will help you to handle all the business failures of your code. And if you define your domain error union type properly, the code will be more readable, and you will get better understanding of your flow. So the short list of the recommendations: model your business failures properly, use API client category to collapse the error cases into one just invalid request something, only map the domain error to the HTTP response on the controller boundary layer, and don't design unexpected exceptions, unexpected errors into your domain error union type. So here's the list, how to migrate your project to this approach. And come to conclude our presentation. This approach is not about avoiding exceptions. It's about making expected failures part of the contract. So in total, your business failures become typed, reviewable, documented API contracts, and the signature should tell the truth. That's it. Thank you for listening.
Thank you so much. Thank you, Sergei. Do we have any questions? Don't forget, any questions deserves a Tumblr. So any questions about Java, about Kotlin, about error handling in general? Yeah, well.
What is better? What is better, Java or Kotlin?
For my experience, Kotlin has more rich compiler and more syntax sugar, and it has a nullable type. So for me, I would say I choose Kotlin. Thank you for the question.
Hello. Yeah. Uh,
Yeah, I see you.
so my question is about the error, like the logic to solve the business error. How to know like the number of error doesn't grow too much, and when the like API is in a production, if a new error, like how to update, like how many error to handle and keep track of this error.
So you should start from thinking when you need to add more error, what category of error would it be? Is it something that you expect to get from the unhealthy app, or and your user will not see that? So if that's the case, you just collapse this error to the existing one. So for you can use for bad request 400 and or not found or config something. But if your error you need to show for the user, and your designers, they have a design how to show, so you expect that. So if your error is an expected business failure, you can distinguish it and you can add the new one. It depends, can user see the error, or you just protect your API. If you just protect your API from the unhealthy API client, you don't need to add a new error case. But if it is if a user can experience that, so in that case you need to encode it in your union type, I think. Thank you for the question.
Wait. We have more. Over there.
Yeah, I see the hand here.
Yes, hello. I have a question. So,
Okay, I see
if
you.
you
Yes.
if you don't mind sharing your workflow, like how do you enforce these rules at scale? So I imagine maybe expectations shift and you expect it to ship a lot more code. So if you generate code, then how do you verify that all of these rules are satisfied in your experience?
So for now, I think most of the Java developers, they do mostly vibe coding and they do agentic coding. So you can just use your rules for the agent, like agents markdown file, and you can just tell the agent to use this approach, to not throw the runtime exception, and to use a union type. And they usually follow the rules. And also, if you have some code, existing code with this approach, the agent will just inherit it, and it will just follow the approach. And to validate it, you can just review the interfaces, the class contracts, and if the agent or your other software developers and you do code review, if they follow the approach, they will use the either or the error union type inside the class contracts.
Okay, thank you.
Thank you for the question.
I think someone raised.
Hi, this is Siam. I'm a Java Spring developer. So I have one question about the migration, especially which one, like which way you prefer to do the migration, using Flyaway or Hibernate PDL?
This question is a bit out of scope of the presentation, but for me personally, I use Flyway, and I recommend to use Flyway for the SQL migrations. Did I answer the question?
Yeah, thank you.
I see the hand here.
Me too.
One more.
Thanks for sharing. I really love Go because it uses explicit tuple-like error returns. But since you've explained the concept of either, what I worry about this mechanism is that there might be a too much wrapper around it, and I'm curious about how do you leverage this downside, and how your team are conscious about.
If I understand the question, your concern is about the wrappers. You need to do like mapping, a lot of mapping to work with either. So this is a disadvantage of the approach. But for example, for Java developers, they should work with the optional type, and it also does some wrappers mapping. And so if you accept the optional in Java programming, you can accept the either also. So for the backend development, I don't know what kind of project you should have to feel the performance bottleneck with the either. I think only if you do some trading or something, which is not a common case. For example, in Kotlin, since they proposed the Kotlin rich errors, if you are concerned about wrapping, the Kotlin rich errors should be very lightweight because they do mapping on the compiler compilation step, and it should feel same how you work with nullable. So for the efficient working with this approach, I recommend you to use Kotlin and to wait for the Kotlin rich errors to get into the stable version.
All right, we have time for one more question.
Thank you. It's here, John. And as I have worked with Flutter and now Nest.js backend, my question is, for example, like now we know our code, yeah? And in this code, like we are like creating the sealed interfaces based on our code, where for example, errors can happen. For example, let's say process payment, and the error comes from the cards. For example, like card expiry or inefficient funds. In that case, if the card is like sending us like general error, how we can know if it's insufficient or card expired? Yes.
So if you try to design or implement some payment API, and you have your card provider integration, and you should ask for the card provider API to provide you the way to distinguish the error cases, so you can reflect them in your API, in your Kotlin domain union types. But in case you cannot distinguish it, this approach cannot help you. So it depends on your case and your top API integration. So as I said, you can use the adapter approach, and if your card provider integration does any runtime exception throwing, and you can handle it and manipulate it, and you have a way to distinguish the insufficient balance and other business failure, you can use the adapter approach.
All right, thank you so much, Sergei. Thank you so much. Big round of applause again.
Thank you, everyone.